Okay, this is the recording for Kevin and Austin's Lightbulb project. I'm just showing you a couple things here that you need. You need a clear disc with holes for it for the LEDs, and we have here a housing for my halogen bulb. This is an LED, which you should know by now. This is a resistor. This is a 100 ohm resistor. It's matched to our circuit, which is designed to use 3 LEDs in series with a 100 ohm current limiting resistor. We're going to need some super glue. You might need this wire. It's just some uninsulated copper tin wire pliers, and sandpaper, which is good for roughing up the leads if you can't get a good lead, and of course solder. And finally, this is a 40-watt soldering iron with a bad tip, so you'll see me struggling a lot with the soldering. And finally, a wet sponge. Let's see. So first thing, you want to go ahead and put the LED through the hole, and we're just going to line them up. You want to have the positive to negative, positive to negative in a group of 3. So we're going to wire the positive, or the anode of one end to the cathode of the next one. And so you just push them through, and then we're going to, see, it looks real nice, doesn't it? And we're going to glue them in place. I actually had to make this plate myself. Austin helped me with that. I machined it using a drill press, a jigsaw, and the drill press again, which I put a bolt through the middle hole and then used a drill bit as a sort of a chisel, I guess, to sand it down, make it smooth. Real nice. So you just want to dab it on the edges, and be careful about the fumes. Get you pretty high if you're not careful. And so you just dab it on there. Now we're starting the soldering. So what I did was just bend the legs down from one to the other, making a little bridge. You should across them. And if this is your first time soldering, the key is to heat the leads, heat the metal part, and apply the solder to the leads, rather than melt the solder onto the metal with the iron. You'll see the solder actually flow into the joint, and it makes a much stronger joint in that case because it's sort of welded or chemically bound, if you want to say, something along those lines. And I'm not sure if blowing on it is the proper technique, but it works for me. So now we've got our group of 3. We're going to make 5 groups of 3 in this project. And I'm going to go ahead and glue in some more. You're going to want to clip off the leads. You're going to want to leave a positive lead left on one end and a negative lead left on the other, and in between you'll clip off 2 of the leads. That'd be my cat. He's helping. I'm just going to glue the rest of them in. Now it's up to you whether you want to glue in 3, solder them, clip them, glue in 3, solder them, clip them. I use sort of a hybrid, but you'll get to a point where you can't really reach, and that's not a lot of fun. And it's good to use your pliers. A lot of people have vices, so you can sort of hold it in place. That's really the best way to go. I don't have a bench vise or anything like that, so I just sort of lay the pliers on them to hold it down, so it doesn't skid around while you're soldering. And you kind of bend the leads out of the way. So if your tip is a little corroded, it's not working so well, it doesn't really transfer the heat as well as a new tip, properly tinned, I find it's good to melt a little solder on the tip before you apply it, brush it off, get real shiny, and then you kind of have to push a little harder. Anyway, it just helps conduct the heat to the joint you're soldering much better than your rusty old iron with a crappy Radio Shack tip. And this, you will get frustrated. It will skid around. Your joints will blob together sometimes if you're not too careful. Be very sparing with the solder. Don't use the thick, ridiculous solder that I'm using. Use 6337 or better. That's really good because it melts at a low temperature, but it also solidifies at the same temperature. It's very quick. It doesn't have a lot of time for it to. Doesn't give you a lot of time to basically break the joint after you've made it. You clip off the leads, and then what we're going to do is bend together the positive leads from each group to another group. Hopefully you've done it to where you have several groups that are next to each other where you can line them up like that. I did mine a bit backwards, unfortunately. I'm not licking it, I promise, I'm just blowing on it. Anyway, so you're going to put those together in groups, and then you're not going to connect the negative ends like that. What you're actually going to end up doing is tying some resistors to all of those. You see here, I've clipped off all but the negative leads. These are all grouped together. And doesn't look half bad, if I might say so myself. Here we have a little resistor pack together. See, it's like a little spindly spider type thing. And you're just going to try to distribute that. If you want to plan ahead, it'd be a great idea to get your negative leads all on the outside edges. Not really possible to do like that all the time, depending on how your disc is shaped. So you set them together, and then we come with this little weird little mushroom thing from outer space, and that's going to be your negative end basically. And the next step is just to take a couple wires, positive and negative. Positive will go to the groups you sew together. Use some jumpers to connect them. Put the negative wire on there to the resistors, and you're going to want to straighten them out a little bit. Here I'm just testing it to make sure that it works. It's pretty bright. This is I think a 15-volt adapter, probably drops down to 12 volts with the load on it. And you've got a male end and a female end here. No laughter, no jokes. So you just want to line them up. You probably have to squeeze in your leads from the sides a little bit so it fits. Clip off the end of your resistor pack after you solder the wire. Solder the wire at the base of it. Not right at the resistor, so you don't want to melt the insulation at all, but keep it short. It's a pretty tight fit in there. And resist here should just jam it in, because you will possibly break a solder lead, or even the lead of a component, like an LED. Pretty much impossible to fix at that point. You'll have to throw it away and grab another. And if you're doing a project for school, they probably only gave you a limited amount. So you want to go by and try to glue it in place, and you'll probably find that hot glue works a little better than this, but I don't have a hot glue gun. So you're going to keep trying to get it in there, and it's not going to dry. So what you do is you graciously ask your wife to help you, because you're probably an idiot and didn't think about this beforehand. I don't want to say probably you're an idiot, but I know I am. So anyway, you let her do the fun part, brush the glue on as you turn it, and be nice also, because when this project is done, you're still going to have to be around there, so just think about that. It's not like a coworker. So brush it around the rim, push it in, and let it sit. Let's fire this up. So do not get the leads mixed up. You will burn out your LED and you'll have to start over. Alright, now we've got a little spotlight there, and all is well. Thanks for watching.